Hello everybody, this is Tom from everystepcalculus.com. I'm going to do a related rates problem right off the internet. And this problem was the first when I searched related rates for a sphere. And related rates has always got some sort of formula to it. They deal with cones and spheres and cylinders. And this one is a sphere, so we're going to get started. Index 8 to go to my Calculus 1 menu. And you can go up or down on this scroll up or down, but I like to go up if the letter is R there with related rates, which is closer to Z than A. And wait for it to load here. And you can see this arrow here on any menu. It shows you that there's more to it than that. They're all in alphabetical order, so sphere would be in the S section. Here's sphere. And in the problem that was on the YouTube, you're asked to find dV dt. In other words, how much is the volume changing with a change in radius. And so we're going to choose number 2 to do that. And the radius rate that they give you is 4, so to enter anything into these entry lines in my programs, any of my programs, you have to press alpha first, alpha 4. And the problem says it's increasing. We're going to choose number 2. You can scroll to it here, or you can choose the number before it. I like to choose the number before, it's quicker. And it says per second. We're going to choose that. And then he gives a diameter instead of the radius, but the formula is with radius, so it needs to be converted, but he gives you diameter. One of the tricks in calculus or physics, they love to trick you. And so the diameter is alpha. He gives it alpha 80. And which is the radius of 40 divided by 2. And he gives millimeters. Notice how many variables there are in this problem. In other words, millimeters per second, the related rate for the radius, and a change in the volume. So you got many things. This one he gives millimeters, so we're going to choose that. I'll show you what you've entered so you can change it if you want. Notice it's millimeters cubed per second, and the radius is millimeters. Then they have to be the same. I say it's okay. You write this all in your paper. Here's the computation of the actual formula within related rates. In other words, you're taking the derivative versus with respect to time of both sides of the equation. Here's v and here's the right side, and that turns into 4 pi r squared dr dt. Then you add the variables here, and what comes up is 25,600 pi millimeters cubed per second. Now notice that you get 100% on this problem, but if you had minutes, you'd have been wrong. If you had feet, you'd been wrong, etc. So the program catches all this stuff, so you get 100% on it. Fabulous program, one of the best I've written. Go to my site, buy my program and pass calculus, and if you want, you can subscribe to me also and see future movies and enjoy my programs as I show them, and also a blog.